Welcome to this special topic in chemistry, redox reactions. So, as we were studying chemistry, we have been coming across this word oxidation and reduction. I could at some point mention that a substance has been oxidized or reduced. What does it mean? So, we're going to look at two processes, oxidation and reduction. We're going to start with oxidation. So, reduction and oxidation can be defined in terms of oxygen, hydrogen, and electrons. So, there are three definitions. Actually, there are four, but one is not in the syllabus. So, there are three definitions. So, each definition can be based either on oxygen, hydrogen, or an electron. So we'll start with oxidation. So oxidation in terms of oxygen is defined as the addition of oxygen to a chemical substance. So when you add oxygen to a chemical substance, we say that substance has been oxidized. Example, when magnesium reacts with oxygen, what's going to be formed is magnesium oxide. So we say magnesium has been oxidized to mean it has gained oxygen. Another one is this reaction where iron oxide reacts with oxygen, where it becomes this oxide of iron. As you can see, it has gained two more oxygens. Initially, it had one oxygen, but now it has three oxygens. Okay, so by the way we write chemical compounds, make sure that these numbers 2, 2, 3, they are small. Okay, not big like me. It's just that some typing issues here. Okay, so this ion has gained more oxygen, therefore it has been oxidized. Next, we look at the definition that is centered on hydrogen, which is the removal of hydrogen from a chemical substance. So if hydrogen has been removed from a chemical substance, we say the substance has been oxidized. So here's an example. So we can have ammonia here breaking into nitrogen and hydrogen. So we can see that hydrogen has been removed from ammonia. So we can say ammonia has been oxidized. The next one is this here, where hydrogen sulfide reacts with chlorine. When that happens, we say hydrogen sulfide has been oxidized. Why? Because it had two hydrogens, but it has lost the two hydrogens. Okay, so the other definition involves electrons. So in terms of electrons, we can say oxidation is just loss of electrons from a chemical substance. So when something loses electrons, we say it has been oxidized. So when something loses electrons, we say it has been oxidized. So here's an example. Copper can break down to form its ion by removing these two electrons. So in this case, we say copper has been oxidized. Another one is aluminium, also losing 3 electrons. We say aluminium has been oxidized. Another one is chlorine. So this one for chlorine, we have this chlorine ion. So for this chlorine ion to form the chloride molecule, it has to lose 2 electrons. Okay, so when it loses 2 electrons, it forms the chloride molecule. Of course, it is formed by 2 chlorine ions, as you can see here. So as long as an electron has been lost, we say it has been oxidized. Next, we look at the process called reduction. So reduction can also be defined in terms of oxygen, in terms of hydrogen, in terms of electrons. In terms of oxygen, it is the removal of oxygen from a chemical substance. Here are some examples. So carbon dioxide, when it reacts with carbon, it forms carbon monoxide. Okay, so oxygen has been removed from carbon dioxide, so we can say carbon dioxide has been reduced. Another one is this one, which involves lead oxide. So lead oxide, when it reacts with hydrogen, forms lead. Okay, so the oxygen that was on lead oxide has been removed. So we say lead oxide has been reduced. The other one is the reaction of carbon monoxide with iron oxide. So when this happens, we're going to have iron and carbon dioxide being removed. Okay, so when this has happened, we can see that the iron oxide had 3 oxygens. Now it doesn't have any oxygen, so we can say iron 3 oxide has been reduced to iron by the removal of oxygen. So reduction can also be defined in terms of hydrogen. In such a case, it is defined as the addition of hydrogen to a chemical substance. Here are some examples. We can have nitrogen reacting with hydrogen to form ammonia. So in such a reaction, we can say, and I hope you are, for those who have done non-metals, you are able to recognize some of these equations. They are there in metals and non-metals. So this is the production of ammonia in Haber process. So here we can see that hydrogen is going to be added to nitrogen. So we can say nitrogen has been reduced. The second one is this reaction here, where hydrogen, as you can see here, just a sec. So here we have 4 hydrogens, but here we have 6 hydrogens. So we can say ethene has been reduced to ethane by the addition of hydrogen. Okay, so this is ethane, this is ethene. We're going to learn about this in organic chemistry. Another one is the reaction of carbon and hydrogen. So in this reaction, we can see that hydrogen is added to carbon. So we can say carbon has been reduced to ethane by the addition of hydrogen. This is ethane from organic chemistry. We're going to take a look at reduction in terms of electrons now. So reduction in terms of electrons can be defined as the gain of electrons. So here are some examples of reactions where there is a gain of electrons. Copper ion can gain 2 electrons to reform copper. So this is a reduction process, and we say copper has been reduced. Again, we can have choline reacting or 2 electrons being added to the choline molecule. We're going to get 2 choline ions. So in this case, the choline molecule has been reduced to chloride ions by gaining 2 electrons. Next, we take a look at oxidizing agents and reducing agents. What are oxidizing agents? So an oxidizing agent is a chemical substance which brings about oxidation of another substance but end up being reduced. So in short, this is a substance whose presence makes another substance to be oxidized. But for that to happen, it's going to be reduced. As you are going to see, these reactions, oxidation and reduction reactions, they occur simultaneously. When one thing is being oxidized, that one is going to be reduced. So the oxidizing agent is going to make sure that something is oxidized, but in the process, it's going to be reduced. So examples of oxidizing agents are oxygen, chlorine, hydrogen peroxide, potassium permanganate, manganese dioxide, and concentrated sulfuric acid. So as you are studying metals and non-metals, you are going to appreciate why these substances are used to prepare some non-metals. Okay. Next, we look at characteristics of oxidizing agents. The first characteristic is they supply or donate oxygen to another substance. Let's take a look at this reaction where lead oxide reacts with hydrogen, form lead and water. What has been oxidized in this case? What has been oxidized here? It's H2 hydrogen. Why? Because it has gained oxygen. Therefore, it means this lead here, lead oxide, is an oxidizing agent. Why? Because it has made hydrogen to gain oxygen. Okay, so in short, lead 2 oxide is an oxidizing agent because it has donated oxygen to hydrogen. The other characteristic is they remove hydrogen from another substance. So here's an example. We have hydrogen sulfide reacting with chlorine to form hydrogen chloride and sulfur. So we can see that this chlorine here has removed the hydrogen from sulfide, okay, from hydrogen sulfide. Therefore, chlorine is an oxidizing agent because it has removed hydrogen from hydrogen sulfide. So in short, chlorine is an oxidizing agent because it has removed hydrogen from the hydrogen sulfide. The last one is accept electrons from another substance. So the last one is accept electrons from another substance. Next, we look at reducing agents. Okay, they are also called the reductants. So a reducing agent is a chemical substance which brings about reduction but end up being oxidized. So this is just the opposite of an oxidizing agent. So examples of reducing agents include hydrogen, carbon monoxide, carbon, ammonia, hydrogen sulfide, sulfur dioxide. So these are reducing agents. So those are reducing agents. So what are some of the characteristics of a reducing agent? First, it removes oxygen from another substance. So an example which we have looked at already is this reaction where carbon monoxide reacts with iron oxide to form iron and carbon dioxide. So in this reaction, what is a reducing agent? So we can see that the carbon monoxide removes the oxygen here. Therefore, since it removes the oxygen, therefore carbon monoxide is the reducing agent. Then iron oxide is the one that's been reduced. Okay, so so here we can say carbon monoxide is a reducing agent because it has removed oxygen from iron 3 oxide. Another definition is it donates or supplies hydrogen to another substance. We look at the same reaction which we looked at where hydrogen sulfide reacts with chlorine. So we can see that the hydrogen sulfide gives hydrogen to chlorine. Okay, when we're looking at chlorine being the oxidizing agent, we said chlorine is removing the hydrogen from hydrogen sulfide. But if we look at it in terms of higher reducing agent, so hydrogen sulfide donates hydrogen to chlorine. So hydrogen sulfide is a reducing agent. The last characteristic is it donates electrons to another substance. So we look at the test for reducing agents. Reducing agents can be tested by using acidified potassium permanganate or acidified potassium dichromate. So how? So reducing agents change the color of the solution of potassium permanganate from purple to colorless. Okay, so if you get a substance, if you put it in potassium permanganate, if the color changes from purple to colorless, then it's a reducing agent. Reducing agents can also change expression of acidified potassium dichromate from orange to green. Okay, they can change a solution of acidified potassium dichromate from orange to green. We also take a look at test for oxidizing agents. So an oxidizing agent can be tested by using acidified potassium iodide or concentrated hydrochloric acid. So what's the behavior? So oxidizing agents liberate iodine from a solution of acidified potassium iodide. So you get potassium iodide, you react it with any substance you expect or that you want to see if it's an oxidizing agent. If it gives out iodide, then it's an oxidizing agent. They also turn most starch iodide paper from white to blue. So you get a most starch iodide paper, you react it with an oxidizing agent or suspected oxidizing agent, it will change from white to blue. Next, we look at redox reactions. So reduction and oxidation reactions, like I mentioned, are called redox reactions because they occur simultaneously. When one substance is reduced, the other one is oxidized. So redox reactions, they are reactions in which one substance is reduced and the other one is oxidized at the same time. So here are some examples. So if you look at this one, we can see that iron has oxygen. After the end of the reaction, it becomes without oxygen, so it has been reduced. Well, on the other hand, aluminium doesn't have oxygen, then it has oxygen, so it has been oxidized. So this is a redox reaction because it involves both reduction and oxidation. So another example is this one. We have lead oxide here and hydrogen. So you can see lead oxide at the end of the reaction becomes lead. It loses oxygen, therefore it has been reduced. While hydrogen gains oxygen, therefore it has been oxidized. Another examples are these. So here we have copper oxide reacts with ammonia. So you can see that at the end of the day, copper becomes just copper. It loses the oxygen, therefore it has been reduced. Well, the ammonia here will break into nitrogen, and the hydrogen in the ammonia will get the oxygen. So it has been oxidized. Another one here. By the way, the other way in which you can look at this, you can look at it as the ammonia loses the hydrogen, so it becomes nitrogen, so it has been oxidized. So the other one, we're going to look at it in terms of electrons. We have zinc and copper, two ions reacting. So when this happens, zinc is going to lose two electrons, okay, and copper 2 ion is going to gain two electrons. So since zinc has lost electrons, we say it has been oxidized, and copper 2 ion has gained electrons, we say it has been reduced. So this marks the end of this interesting and short topic. Happy solving.